Okay, so today you all need a calculator, an orange periodic table, and one set of color pencil. First, you go get that, and I'm going to teach you how to calculate the average atomic mass. That's a number you are seeing under each element on your periodic table, okay, which is called average atomic mass. We are going to figure out why the atomic mass on periodic table is not a whole number. The reason is the atomic mass on the periodic table is the weighted average of all isotopes. Go ahead and write average on the first blank and isotopes on the second blank. Okay. Now let's see the difference between the mass number, which we have used in isotopes, and the average atomic mass, which is on the periodic table. Okay, I'm going to write an example. Say, if I wrote an isotope name, which is chlorine hyphen 35, this whole number is called mass number. But when you look at the periodic table under chlorine, you can see 35.45. It's a decimal number, which is the average atomic mass. So we are going to see the definition and the difference between these two. Okay, so mass number is the mass of one specific isotope. Mass number, it is the mass of one isotope, one specific isotope. We can calculate that mass number by adding protons and neutrons. Remember, ape man, we are adding P plus N to get the mass number. So that is always a whole number. Okay. Then when we look at the average atomic mass, it's the weighted average of all isotopes, not just one. And it can be calculated, and you can find that on the periodic table, which may be a decimal number most of the time. Sometimes for few elements we can see a whole number too. So I'm going to teach you how to do the weighted average. So we will take one example, which is familiar for you, is calculating a weighted average of grades. Okay, so here one student want to see whether she will get an A on her chemistry quarter grade. Okay, as per the syllabus, it says all of his grade, the 50% of will be from the test, 20% from labs and quizzes, and 30% from homework. And she scored an average of 95 on her all test, and lab average is 86, and her homework average is 84. So this is how we are calculating the regular average. You all know that. Add all these numbers, you will get a big number. Then there are 3 grades, so you will divide with the 3, and this will be the regular average. Now I'm going to show you how to get a weighted average. Okay, so let's go back to the question. It says 50% of the test. So you have to convert this 50% into a decimal. How will you convert a percentage into a decimal? If you don't know, that is just divide with 100, because percentage is something out of 100. So you can easily move the decimal place 2 places to the left. So 50 will be 0.50. If you want to add a 0 in front of that, that's fine. So 50 percentage is in decimal is 0.50. Then multiply that with her test grade, which is 95. So get your calculator and multiply that and round that to two numbers, which is 48. Next one, it is 20 percentage of her lab. So convert the 20 into decimal, which is 0.20 times her lab average is 86. When you do the calculation, you will get 17.2, or I'm going to round that to 17. Then finally, it is 30 percentage of her homework, which is 0.30, and the homework grade is 84. So multiply 0.3 times 84, you will get 25.2. I rounded that to 25. So if you add all of them together, you will get 90. So this is the weighted average. Okay. Which way you would want to grade, calculate, you decide. Okay. So I'm going to take chemistry example now. Again, the definition one more time. Average atomic mass, which is the weighted average of all natural isotope based on their percentage. The terminology we are using, abundance. Abundance means their percentage of occurrence. How much percentage are there in the earth crust? Okay, so here on your periodic table, you can see the weighted average of chlorine is 35.45, and I'm going to show you how to get that number. Okay, so it says 75 percentage of chlorine 35 and 24 percentage of chlorine 37. So convert this 75.7 into decimal. That means you are moving that into like 2 decimal positions. So you will get 0.757. And the mass of each isotope is 35. So you are going to multiply the 0.757 times 35. The unit is given, which is AMU. So you're basically multiplying 757 with the 37. So go ahead and multiply 0.757 times 35, which is 26.495. If you want to round that to 2 decimal place, you can do that, or we will do that at the end. So we basically did multiply percentage times mass. Okay, repeat that for the second one. There is 24.2 percentage. Convert that into decimal, which is 0.242. Okay, and the mass of that isotope is 37. So you're going to multiply that with 37. So get your calculator and multiply 2.242 times 37. And you will get 8.954. Then add these numbers together, you will get 35.449. I'm going to round that to 2 decimal place, so we will round that up. So the answer is 35.45, which is the exact value you will see on the periodic table. Okay, let's move on to the next question. Okay, it's already done for you. I'll go over it. So there are 3 isotopes here given. One is magnesium 24, which has a 78.7%. So go ahead and convert 78.87 into percentage, which is 0.787, times that with 24. You will get 18.888. Then 10.13, which is 0.1013 times 25, you will get 2.5325. Repeat that for the third one, which is 11.17, which is 0.117 times 26, you will get this number. You are adding everything and round to 2 decimal place and you will get 24.32. Okay, stop the video and try the next one, or you can do that as a homework. And when I come back on Tuesday, I will check your note packet for this question. And we will do more practice next class. Okay, now we are going to do periodic table classification. Okay, so the periodic table you are using right now, which is developed by many scientists. So there are multiple scientists worked behind the development of that, but we are talking about only 2 scientists who had a major contribution on the periodic table right now we are using. Okay, the first one is Mendeleev. Dmitry Mendeleev is the scientist who started designing the periodic table right now we are using. He is considered as the father of periodic table. He arranged all the elements in the increasing order of atomic mass. So he arranged all the elements in the increasing order of atomic mass. And he found that all the elements with the same property comes in same column. We would say that is group. And he also did a big thing. While on his time, which is on 860, there was only less than 60 elements discovered. So he found that when he arranged them in the increasing order, some of the elements are missing. So he left blank space for undiscovered elements. Undiscovered elements. So that was a big contribution because the scientists during that period will get an idea about, oh, we have to find these elements between maybe chlorine and bromine or something like that. But mostly found a mistake on Mendeleev's periodic table. If you look at argon, which is 18, the mass of argon is 39.9 something. After that, potassium coming, potassium is 39.09. So, which is basically in a decreasing order. So, mostly said we have to arrange elements or the order he followed. Instead of atomic mass, we have to use atomic number. That is the only correction made by mostly. Periodic table looks exactly the same. He didn't change any elements, but he only changed the definition or the criteria used by Mendeleev from atomic mass to atomic number. And he also found that the same elements with the same property comes in same column. Okay, now look at the periodic table. We are going to see some of the properties. Okay, on your periodic table, there are 18 columns you can see. That columns are called groups. So groups are columns on the periodic table. It's like vertical column from top to bottom. So if we know the column number 1, we can say there is 1 valence electron. Or if it is column number 17, it is 7 valence electron. So it represents the valence electron, which is the electrons in the valence shell. And there are 7 periods in the periodic table, which is the horizontal rows, which represents the energy level. So if they are in first row, there will be only 1 energy level. Second row, they have 2 energy level. Third row, they will have 3 energy level, and so on. Okay. And on your periodic table, you can see the orange periodic table. You can see a stair symbol, like a stairs. Everything left of that, okay, everything on the left side of that periodic table, we will call them metals. Okay, one exception is that is hydrogen. So when you think about metals, you have seen many metals like iron, aluminum, copper, silver, gold, etc. So the properties of metals, we know that they are hard and strong, they are shiny, they are heavy. We can say they have high density. Next property, they are malleable. Malleable means if we beat metal, we can make a thin sheet out of it. That's how we are making aluminum foil, then gold foil, all those things we can make it. And they are also called ductile. Ductile means if you stretch a metal, we can draw wires, like we can make thin wires out of it. That's how we are making electrical wires, jewelries, all those things. And one important property, they will allow electricity and heat to pass through the metals. So they are called good conductors of heat and electricity. That's why we are using metal utensils to cook. Okay, now everything above the stairs, like the right side of the stairs, I'll use a different color. So right side of the stairs are called known metals. The properties of known metals are exactly opposite that of metals. So if you burn a wood, you will get a black color substance which is called, that is carbon, which is a known metal. Okay, carbon is a known metal. So carbon is dull, is brittle. That means if we beat them, they are not malleable and ductile. They will break easily and they have low density compared to metals. and they will never conduct electricity. They are called insulators. They are but conductors of heat and electricity. Also, when you look at the periodic table, you can see there are solids, there are liquids and gases. Okay, everything in red are gases. Everything in blue is liquid. There is only one liquid, which is bromine. And all black color are solids. And there are few elements touching on the stairs. Those are having both the properties of metals and non-metals. And we will call them metalloids. Okay. They are touching the staircase, only exception aluminum. Okay, they will show both the properties of metals and non-metals. Okay, now, as I said, you need color pencils. Okay, first we are going to label the number of valence electron only on the main group. Okay, then we will color metals with blue, metalloids with yellow, and non-metals with red. Okay, let's do that first. I'm gonna write the valence electron for everything. Okay, group number 1, which is the main group, which has one valence electron. Group number 2, write 2. And skip this. You are skipping the middle block of elements. And 13 is 3, 14, 4, 15, 5, 16, 6, 17, 7, and 18, 8. Okay, then I'm highlighting the stairs. Okay, so now you all need blue color. So get a blue color and highlight or color all metals in blue. So except hydrogen, you have to do everything on the left of the stairs. Including the bottom ones. So do not color hydrogen, okay? Hydrogen is okay. So we are done with the metals. Now we have to we are going to color metalloids in yellow. So first metalloid is boron. He is sitting on that stair. Next one is silicon. He is also sitting on that stair. Then arsenic. Then tellurium. And you can skip the astatin, okay? And I'm skipping aluminum. Next one is germanium. Sb antimony. Then do the polonium. Polonium is radioactive. We don't need to color that, but still go ahead and do that. Okay, now we need a red color. If you are not done, you can pause the video and then continue later, okay? All non-metals, I'm going to color that with the red, okay? So, these are in red. And also, I'm going to color the hydrogen. Use a lighter color so that you can read it. I can't do that because this one. Hydrogen is with the red color. So we can see all blues are metals, all yellows are metalloids, and all reds are non-metals. Okay, now you need more colors. We are going to label alkaline earth metals. Alkali metals, halogens, okay. So you need a red color. We are going to label the first group except hydrogen, okay. Let me find if there is a lighter color. No. Okay, so you're going to label everything in group 1. And they are the name, you have to memorize the name. They are called alkali metals. One second. So they are called alkali metals. ALKALI. They are very reactive. Okay. Now we need a blue color. For the second group. Color everything. Okay. And they are called alkaline earth metal. The spellings are here if you want to copy that from there. Or just draw a line if you are. They are called alkaline earth metals. The name is here. Okay, then next we need yellow color. So we are going to highlight groups number 17, which is this group. And the name of that group is they are called halogens. Okay, now we need a green color. We are going to color the last group. In green color. They are called noble gases or inert gas. They are called noble gases or inert. They won't react. Inert gases. Okay, now we are going to pick orange color and you are coloring everything from 3 to 12 like a block. Okay, they are called transition metals. They are called transition metals because they are showing a transition of behavior from metals to non-metals. Okay. Now we are going to the bottom line, get a purple color. And highlight the first row. This is not purple. Okay, highlight the first row with purple, and they are called lanthanide series because they are starting from lanthanum. Okay, the last one is pink color. We need pink color. Highlight everything on the last row. And write the name actinide. Okay, we will stop here. Then you are going to take the progress check and will complete these notes when I come back in class on Friday, Tuesday. That's it for today.